Hello.
Hello. Can you hear me?
Yes.
Okay. Yeah. So Daniel is applying for an internship position at Amazon. And he asked me to run this mock session. It's going to be a coding one. So at Amazon we have different types of coding interviews. Like one of them is to test if the person knows data structures. The other one is about more problem solving skills, and the third one is about maintainability, if the person has experience to write maintainable readable code. So is there anything specific you were interested in, or I can choose whatever I want?
Whatever you want.
Okay, then let's see what your data structure knowledge is. So tell me about different data structures that you know.
About, what did you say? Any?
Yeah, any data structures.
Okay. Arrays, queues, stacks, priority queues, hash maps, tree maps. Just trees. I mean, binary trees, graphs, binary search trees.
Okay.
Okay. Yeah, I think that's it.
So if to speak about the trees, yeah, can you tell me a bit more about what the tree is?
Okay, tree is a collection of nodes which are connected and not forming cycles. Yeah, they consist of nodes, and nodes are just are themselves kind of a class instance or struct instance, which themselves have link maybe to their parent, link to their neighboring nodes, and the values.
Okay.
Usually, yeah.
Okay, yeah, sounds good. And do you know about properties of a binary search tree? Well, what is binary tree? First of all, let's try to talk about it. What are the
binary tree? Yeah, binary tree is a tree where every node has up to children. Let's say children. It can be you can say neighboring nodes if it were a graph, but I think yeah, it's more right to say if they have children left and right up to two nodes. Yeah, it's just a binary tree.
Okay. Any other properties
of a binary tree? No, no.
Do you know what a traversal of a tree means?
Yes, traversal
Okay.
tree where okay, do you want me to give you a definition of
Yeah, what kind of what is traversal, or what kind of traversal types you know?
Yeah, I know three types of traversals: in-order traversal, pre-order traversal, and post-order traversal.
Okay, can you elaborate more on each of them?
Yes, of course. So pre-order traversal is where you first visit the node itself and then visit the left child and right child.
Okay.
Yeah, and in-order traversal is where you first visit the left child and then you come to the value of the current node itself, and then you traverse the right child. So maybe it's more right to say like a right subtree and left subtree. Yeah, probably.
So left, root, right? And what about the last one, like post traversal?
Post auto traversal.
Yeah.
It's when you visit the left and right subtree, and then you come to the root value itself.
Okay. Okay. Do you know properties of a BST, binary search tree?
Yeah, binary search tree is just a binary tree, but the restriction is on its values. So the right, the values of a right subtree must be greater than root value, and the values of the left subtree must be less than the root value.
Okay. Do you think you can implement this validation? Like, so like I want you to implement a method, like, or like a function, whatever, to validate that the tree is either binary or not.
See if the tree is binary.
Yeah.
Okay, what am I given?
So yeah, first of all, like here's the link. Let me share it with you. Can you see it?
Mm-hmm. Okay, yeah, I'm here.
Okay, now let me share my screen now. Just a second. Share screen. Choose Firefox. Okay, or like, dude, can you share the screen? I think like I have some security measures. I'm using my laptop.
Okay, I can't share. You have to allow me.
Multiple participants can share simultaneously. Maybe now we can. Can you check it? I just gave you the access.
Yes. Okay, you can see now, right?
Yeah.
Yes.
Yeah, so I want you to implement a method that will verify like it should say like if the given binary tree is binary search tree or not.
Okay. Let's see. I need to return Boolean value. I'm going to be coding in C++, by the way. So I'm just going to say check. Or no, it's this. Okay, and let's say I have this. Is this fine? Is it this way?
Yeah, yeah, sounds good.
Okay. So, okay, let me, if root. So if it's going to be null pointer, should I return false?
So yeah, let's assume you'll. Oh, okay. What exactly do you check? Like you're looking for a null pointer, like for the root, you mean, or what?
if yeah, like
You'll,
the original
you'll only
original
have
tree.
a valid object passed, so don't worry about it.
Okay. So I'm just gonna return true then. Let's say I'm gonna be checking. So binary search tree, right? So it's not balanced, so doesn't have to have left or right subchild, but if it has, then it must follow some rules. So I'm just gonna say tree left will be equal to root left. Okay. And tree right is equal to root right. Okay. If okay. If left exists, if left exists, I have to say that it should be if left exists, and I mean if it's not null pointer, and if left exists, then it should be if left value should be less than the root value. Okay. Well, if it's not, then you can return false. Yeah. If it is, I need to have some. Okay, sorry. I'm just thinking, what should I do right now? Should I just okay, let's try optimizing later. I'm just thinking whether I should create another variable for left subtree. Let's say bool L, which stands for left subtree. Yeah, it's going to be true by default. Okay, no. So it here, and let's say L. If it is, L is going to be true. If that doesn't exist, it should also be true. No, else if. Yeah, else if left doesn't exist. No, else if left does exist and its value is more than that, it should be false. Yeah. It should be false. Well, if left doesn't exist, it should be true. Okay. Yeah, so basically if it is, then I don't have to do anything then.
Quick question, like what is L?
L, yeah. L stands for the, like I'm checking the condition of a left subtree and then root value, like of a left value. Correspondence to the, root form. Yeah, and I'm just gonna do the same for right. Okay, so I can copy this, paste it here. Okay. Okay.
So basically what we're saying is like, let's predefine a variable, like a Boolean variable, left to true, and then to check if it's false, and then you would change it to false, right? And then you do the same for the other one.
Yes.
Okay, okay.
Yeah, and then if either of them false, I can return false right away.
Okay.
Okay, and if it's not, I will have to return. Okay. I think this should probably work.
Okay, do you want to think of some testing cases and lead me through them?
Okay, yes, sure. Let's say we have here, let's say we have like 2. And we have it's gonna be 1. Here we have, let's see, no, that's that. This is, so let's say it's gonna be like 5, and this is gonna be like 15. Okay. And this one, let's say, is 8. And this one let's say it has like 12. So basically it should satisfy. And this is 20. Okay, so this is a binary search tree.
Okay.
Okay, let's take this example. And so we have we have 10 as a root, and we see that it's not null pointer. Yeah. And we create root left and root right. Now I'm just thinking that we don't really have to create this. Okay, but let's say we created root left and root right. And then for left, for the correspondence of a left value and then root value, I will create bool L equal to true, and left is not null pointer, and left val is yeah, it's not greater than or equal to, so it will skip this if, and then bool R, boolean R is also like boolean L, which means correspondence of a right value, just the right child, value of the right child, and then root value. So it's by default true, and right exists. And sorry, if it is less than, yeah, this is a mistake. If it is less than, I guess, equal to, right? So it should not be equal to, yeah, so there is a mistake, I fixed it. And so it's not, this condition is not met, that's why it will skip this if. And so boolean R and boolean L is true, and let's say it's false, it is also false, and then it will return is it will come here is BST root left. So at this point, call stack is on 5. Okay, 5 is not null pointer. Left child is null pointer. Right child is 8. It is by default true. So left is null. That's why it will skip this. R is true. right exists and right value is not less than or equal to, so both of them are true, and neither of them is going to be false. Yeah, no, it's not going to meet this condition. So it will skip this. So it will look at the root left of 5, right? So when it is, it will see that root is null pointer. That's why it will just return true, and then it will come here, and it will come here again. It will come to 5. Before that, yes, it was like let's say it is 10, and this is call stack is 5, and then just null pointer, and then it will come back, and then now it is calling 8. So root is it called the right child of 5. That's why it's here. 8 is not null pointer. Left and right child of 8 are null pointers. So L is true, left doesn't exist. R is true, right doesn't exist. It will skip this, and yeah, yes, it will return root left. It is null pointer. It will return come here, and then root right also null pointer. I'm now looking at the left and right child of 8. Am I being clear, by the way?
Yeah, so good. Yeah, I'm just like let's try to use unhappy case.
Be faster. Okay, yeah, let's just use a happy case. You're saying that another case.
Yeah. Yeah.
Okay. Okay, so let's say, okay, let's say we're here. Let's say, oh yeah, we can do that. So let's say it's 6. Is it fine? Is it unhappy? Is
Yeah, let's do it.
Happy enough? Okay. Okay, so 10. Okay, 10. It's not null pointer. Left and right is going to be 5 and 15. 5, it will come here. Yeah, it does exist. And yeah, by the way, it does exist, and left value is not greater than or equal to. That's why it will skip this if.
Yeah. So
yeah,
let's go straight to 15 because like
okay, now we're at 15. Yeah, okay, now we're at 15, and 15 is not null pointer. Left and 12 and 6. L is true by default. 12 does exist. 12 is not greater than or equal, so it will skip that. R is true. So right does exist, and it is less than or equal to, so it's going to be false. Yeah. So it's going to be false. It will return false. So it will come here. So as this one is true, it will return false. So it will come back here. So right child of 10 is going to be false.
Yeah.
That's why in the end it will return false.
Yeah. Okay. Good. Do you want me to lead through the complexities, like space and time complexity?
Okay. Yes. So first of all, our binary tree, right? Okay. So am I guaranteed that it's going to be a binary tree?
Oh yeah, sure. Like it is definitely a binary.
Yeah, binary tree. Yeah, binary tree. But anyways, binary tree, yeah, has up to two values. So maybe it may be like long, like a linked list, but it's not linked list. But I mean, for everything. So let's say something like this. Yeah, something like this, but it's very long. It's not 3. The depth is not 3. Depth is n. Yeah, if that happens to be the case, so the time complexity of this is O(n). And space complexity is O(1). Oh, I'm sorry. Yeah, sorry, space. I want to say space first because I was talking about depth, and then time complexity. Time complexity is also O(n) because I'm traversing every node.
Okay.
Yeah.
Can you explain like why space is often?
Yeah, basically we have call stack. We have call stack, and call stack is going to be filled with these calls to EastBSD again and again.
Okay.
Okay, understand what I mean? Is that enough?
Yeah, yeah. So like would you do any changes if you have like really huge data sets?
Any changes if we have, sorry, I didn't hear.
If you have huge data set, like you have a lot of data, would you do anything differently?
If we have a lot of data, no.
Yeah, is there anything you would recommend to do, like to make it more optimal than OFN in terms of time complexity?
In terms of time complexity, time complexity wise,
Yeah,
I don't think it's going to be better than O(n) because you anyway have to check every node. I mean, yes, of course, in better cases, you might check that very, very, very root node and then right child or left child does not satisfy the condition. But like as we did in the previous case,
yeah.
the only, yeah, the right child of a last node was not satisfying, and it can be very, very big tree. So I think you have to check all of the nodes. So that's why it's going to be time. It's going to be O(n).
Okay, like if to forget about like the algorithm, okay, let's go back to the data structure itself. Like, what would like what difference like would you need to have a better algorithm, like to have a faster algorithm? What property should this tree have, like to have a faster algorithm?
To have a faster algorithm.
I mean, like not faster, but like to have the time complexity, which is
Okay, time complexity wise, yeah, let's say that it is balanced binary search tree.
okay.
If it is balanced, then it means that level it's just level difference is at most 1. So if we have something like this, oh, I'm sorry, can you hear me?
Yep, I still can.
Okay, yeah, I can hear, but I can't make changes to code share. Okay, yeah, now I can. So I was saying like something like this, like 8. So this is, I don't know.
Yeah, you don't need to do any changes.
Yeah, okay. Let's say we have something like this, and then the height of this tree is going to be log of n.
Okay. Yeah,
So that in that case, the time complexity, oh, sorry, space complexity is going to be of log n.
okay. Yeah, yeah. That's actually everything I wanted to hear. So yeah, I think we can stop here. Thanks.
Can you stop sharing screen?
Yeah, you can stop here. Switch to the feedback.
Okay. If you have time, can we do some algorithm question?
Not sure, I don't have time, but like,
Okay, yeah.
Feedback or like you want to stop now?
No, I want to hear feedback, yes.
Okay, good. Would you mind if I switch back to Russian, or English is fine, is better for you?
No, I mean, whatever you want.
Смотри, еще раз, как я и рассказывал в самом начале, у Амазона есть несколько типов кодинг-интервью. И одно из них — это проверить, что человек обладает знаниями структур данных. И очень часто проверяют кандидатов на знание деревьев, ну, потому что на примере деревьев можно понять получше. Есть различные вопросы на тему деревьев, что можно посмотреть, увидеть, если человек вообще имеет опыт работы с деревьями. В твоем случае мы еще поговорили по теоретической части деревьев. В целом мне это позволило собрать очень много дата-поинтов, которые говорят о том, что ты знаешь, что такое структура данных, как минимум деревья. И я могу заасюмить, что ты, скорее всего, справишься и с задачками, если там будут графы или какие-нибудь другие структуры данных. Учитывая, что ты идешь на стажерскую позицию, ну, по крайней мере, я бы не ожидал, наверное, задач более сложных, и поэтому есть велика вероятность, что тебе могут дать задачу примерно такого же уровня.
Я могу задать вопрос или вы хотите закончить? Окей. То есть я про это не знал. Я думал, типа, везде в стажировках, то есть если на интервью позовут, там, после скрининга или там после онлайн assessment, то будет, типа, 2 технических интервью просто на алгоритмы. А вы, типа, говорите, что будет 3 отдельно первое на data structure, второй алгоритм и третий, я что-то забыл.
Умение писать, поддерживаем.
Но это тоже будет, типа, на основе задачек, да?
Да, это все будет на основе задачек. Во всех 3 интервью тебе нужно будет справиться очень быстро, потому что, как я тебе рассказывал, за 1 час у нас стараются провести 2 типа интервью. Это кодинг, это техническая часть, и поведенческий, по лидерским принципам. Поэтому времени будет немного, и задачи больше. Ну, задача интервью — разобрать дата-поинт, что ты обладаешь нужными знаниями, эти знания выше, в среднем выше бара того уровня, на который ты оплаешься. В данном случае там, по другим стажерам смотреть. Но, опять же, для меня важно, что ты обладаешь этими знаниями. Я могу поставить фидбэк, что да, я собрал data points, они есть, они положительные. Было пару моментов, где можно было улучшить, но, опять же, в силу того, что у тебя опыта прохождения интервью, наверное, не так много, мне приходилось гайдить тебя, что, в принципе, не проблема. Гайдить я имею в виду: расскажи мне о time complexity, расскажи мне об алгоритме и так далее. В идеале, когда проходишь интервью, я бы рекомендовал, наверное, рассказать, что ты хочешь, как ты хочешь решить задачку на словах, прежде чем писать код. И тогда тебя могут уже откорректировать. Сам интервьюер может тебя направить в другую сторону. Может, ему будет этого достаточно. В своем случае ты сразу начал писать код. Я бы не сказал, что это супер критика, учитывая, что ты в итоге сделал так, как ты хотел, ты знал, что решать. И поэтому все получилось нормально. По поводу time и space complexity ты мне сказал правильно. Often ты мне рассказал, почему space будет тоже линейный. Когда я спросил, изменишь ли ты что-нибудь, если у тебя будет очень много данных, то по факту, так как ты забиваешь стек, у тебя будет стек overflow на больших данных, правильно? Можно тоже об этом там, упомянуть, что есть какие-то риски, и как ты будешь их избегать. Да, наверное, ты рассказал про balance tree, когда я спрашивал, если у тебя структура данных, какой property должен быть у дерева, чтобы у тебя было более оптимальное решение, ты тоже ответил. В целом, я бы сказал, достаточно положительно на тему знания структуры данных. Я не знаю о твоих навыках прохождения problem-solving задач. Там уже больше фокуса на какие-то алгоритмы, тебе могут дать задачки по графам, там точно не будет явного, там не будут тебе давать задачку, где тебе нужно будет с какой-то структурой данных поиграться, тебе нужно самому будет предположить, какую структуру данных ты будешь выбирать и так далее. И как ты умеешь подходить к решению задачки, насколько ты можешь декомпозировать, объяснять. Да, один из моментов, который я тоже отметил, ты, когда решал задачку, ты объяснял, что ты делаешь, и это очень хорошо. То есть это ожидается от кандидата. Наверное, так. Если есть какие-то вопросы, можешь спрашивать.
Насколько часто спрашивают динамичное программирование? Оно тоже типа считается обычной темой даже, да?
Я не понял вопроса, повтори, пожалуйста.
Насколько часто встречается динамичное программирование, задачи на эту тему? Оно тоже типа считается одной из тем, да, просто обычной или...
Я думаю, да, стоит ожидать, что будет динамическое программирование. Когда я проходил, у меня был вопрос, но он относительно был несложный. Но не ожидаю, что у тебя все 3 интервью будут на динамическое программирование. То есть в этом плане точно можешь не бояться, потому что у интервьюеров есть задача собрать как можно больше diverse дата-поинтов по разным темам. И поэтому у тебя, если будет задачка, то, скорее всего, когда вы на тему problem-solving будете общаться. А так, 2 другие задачки – это больше на понимание структур данных, знание каких-то базовых алгоритмов и на умение писать читаемый код.
А как считаете, мой код был читаемый?
Вполне, я особо не придирался. Там L, R, допустим, не было понятно. Ты мог бы возвращать ответ в самом if, то есть когда ты делал проверку, ты говорил L equal to false, ты мог сразу возвращать false, то есть тебе даже не нужно было переменную создавать. Но для меня это больше не пик, я лично к таким вещам отношусь очень нормально, особенно если мы говорим о кандидатах на позицию стажеров или graduate, то есть зачастую люди закрывают глаза на маленькие такие недочеты. Если бы ты, конечно, везде использовал имена как ABC, тогда это был бы минус, но у тебя это был...
Да.
Это больше не пик. Таких вещей можно не бояться. В целом у тебя навык вроде бы good. Я сам с C не работал, но, допустим, если говорить о типе интервью maintainable code, like if you have skills to write maintainable code, там важно, чтобы ты понимал, для